Hello friends, in this session we study the concept of state space and the different search that can be used to explore the search space in order to find a solution. Before an artificial intelligence problem can be solved, it must be represented as a state space. So, I have started the session on state space search. First, I have defined the state. State is a representation of problem element at a given moment. Next is state space. A state space is the search to find a solution to the problem, or we can say a state space is a set of all states reachable from the initial state. Based on that, we can say a state space is search to find a solution to the problem. A state space basically consists of a set of nodes representing each state of the problem, arcs between nodes representing the legal move from one state to another, and initial state and goal state. Now, I have discussed on how to build a system to solve a particular problem. For that, we want to describe first is define the problem exactly. Means find input situation as well as final situation from an acceptable solution to the problem. Next is analyze the problem. Means find few important features that may have impact on the appropriate of various possible techniques for solving the problem. Next is isolate and represent task knowledge necessary to solve the problem. Next is choose the best problem solving techniques and apply to the particular problem. So we can say that according to computer science, a problem solving is a part of artificial intelligence, which includes a number of techniques such as algorithm, heuristics to solve a problem. Now we have discussed on state steps performed by problem solving. In this, first we have understand what is goal formulation. It is the first and simplest step in problem solving. It organizes the steps or sequence required to formulate one goal out of multiple goals as well as actions to achieve that goal. Goal formulation is based on the current situation and the steps performs measures. Next is problem formulation. It is the most important step of problem solving, which decide what action should be taken to achieve the formulated goal. There are five components involved in problem formulation, which is initial state. It is the starting state or initial step of a goal. Next is actions. It is the description of the possible action available to the state. Next is transition model. It describes what each action does. Next is goal state. It determines if the given state is a goal state. Next is path cost. It assigns a numeric cost to each path that follows the goal. The problem solving selection a cost function which reflects its performance measures. Remember one thing, friends, an optimal solution has the lowest path cost among all the solutions. So we can say that initial state, actions, and transition model together define the state space of the problem implicitly. State space of a problem is a set of all states which can be reached from the initial state followed by any sequence of actions. The state space forms a directed map or graph where nodes are the states links between the nodes are actions, and the path is a sequence of states connected by the sequence of actions. Now, I have discussed on what is search. It identifies all the best possible sequence of actions to reach the goal state from the current state. It takes a problem as an input and returns solution as its output. Next point is what is solution? It defines the best algorithm out of various algorithms which may be proven as the best optimal solution. Next point is what is execution? It executes the best optimal solution from the searching algorithm to reach the goal state from the current state. Now, I have discussed on which type of examples problems in state space search. Basically, there are two types of problem approach. First is game problems. It is a brief and exact description of the problem which is used by the researchers to compare the performance of algorithm. Second is real world problem. It is real world based problems which requires solution. Unlike a game problem, it does not depend on description, but we can have a general formulation of the problem. Now, I have discussed on 8 puzzle game problem. Here, we have 3 cross 3 matrix with movable tiles, number from 1 to 8 with a blank space. The tile adjacent to the blank space can slide into that space. The objective is to reach a specified goal state. As shown in figure, our task is to convert the start state into goal state by sliding digit into the blank space. The problem formulation is as follows. States means it describes the location of each number tile and the blank tile, like as example which we have taken here. Next is initial state, means we can start from any state as the initial state. If I take this 3 cross 3 matrix, so my initial state can be digit 1, can be digit 4, or it can be digit 7. Next is actions, means action of the blank space is defined based on move. It can be either left, right, up, or down. If I take this 3 cross 3 matrix figure 1 as an example, for in this example we have considered red color digit as a blank space. So as per the example, for digit 1 we can move downside and right side. For digit 3 we can move left side and downside. For digit 7 we can move right side and upside. And for digit 9 we can move left side and upside. So we can say that in this type of condition we can have only two moves. Now see in figure 2 we have another 3 cross 3 matrix. For in this example we have considered red color digit as a blank space. So as per the example, for digit 2 we can move downside, right side and left side. For digit 4 we can move downside, upside and right side. For digit 6 we can move downside, upside and left side. For digit 8 we can move upside, right side and left side. So we can say that in this type of condition we can have only three moves. Now see in figure 3 we have another 3 cross 3 matrix. For in this example we have considered red color digit as a blank space. So, as per the example, for digit 5, we can move left side, upside, right side, and downside. Next is transition model, means it return the resulting state as per the given state and actions. See in figure, based on the initial state, we have performed right side move, upside move, and downside move. Next is goal state, means it identify whether we have reached to correct goal state. Next is path cost, means the path cost is the number of steps in the path where the cost of each step is 1. Now, I have explained some real world problem. First problem is traveling salesman problem, means it is a touring problem where the salesman can visit each city only once. The objective is to find the shortest tour and sell out the stuff in each city. Second problem is VLSI layout problem. Means in this problem, millions of components and connections are positioned on a chip in order to minimize the area, circuit delay, and maximize the manufacturing growth. For that problem, the layout problem is split into two parts. First is cell layout, means the primitive components of the circuit are grouped into cell, each performing its specific function, so that each cell has a fixed space and size. The task is to place the cell on the chip without overlapping each other. Second is channel routing, means it defines a specific route for each wire through the gaps between the cell. Now, I have discussed on measuring problem solving performance. Before discussing different search strategy, the performance measures on an algorithm. Accordingly, there are four ways to measure the performance on an algorithm. First is completeness. It measures if the algorithm guarantee to find a solution if any solution exists. Next is optimality, means it measures if the strategy search from an optimal solution. Next is time complexity, means the time taken by the algorithm to find solution. Next is space complexity, means amount of memory required to perform a search. Remember that the complexity of an algorithm depends on branching factor or maximum number of successor. Depth of the shallowest goal node, means number of steps from root to the path, and the maximum length of any path in the state space. Now, I have explained what is search strategies. There are two types of strategies that describe a solution for a given problem. First is informed search or blind search. This type of search strategy does not have any additional information about the state except the information provided in the problem definition. They can only generate the successor and decide a goal state from a non-goal state. This type of search does not maintain any internal state. That's why it is known as blind search. I explain this with example. If I have start state S and goal state G, and intermediate state A. With the help of intermediate state, we can reach to goal state. So, in uninformed search, we can only know in which coast we can reach our start state to intermediate state. But we cannot know in which coast our intermediate state reach to goal state. Next is informed search or heuristic search. This type of search strategy contains some additional information about the states beyond the problem definition. This search useful problem specific knowledge to find more efficient solution. This search maintains some sort of internal state via heuristic function which provide hints. So it is also called heuristic search. I explain this with example. If I have start state S and goal state G and intermediate state A, with the help of intermediate state, we can reach to goal state. So, in informed search, we can know in which coast we can reach our start state to intermediate state and in which coast our intermediate state reach to goal state. So, thank you friends watching this video. I hope you can understand all the concept of state space search in artificial intelligence. Thank you.